All right, chapter 10 is all about circles, so we're just going to cover the real basics here. A circle is a set of all points that are equidistant from one point. Okay, that point that they're all equidistant from is called the center of the circle. So if we've got a circle, okay, we start with a point, and then we plot all the points that are the same distance away from that one point, and that creates a circle. Okay, so if we name that point in the middle, let's call it P, that's point P. That's also how we name the circle. We say, okay, circle P is this circle. So it's a circle that's centered at P. This distance that goes from the center out to each point, that's called a radius. So it's the distance from the center to a point on the circle. And all radii, so all these radiuses, okay, the plural is radii, are congruent. Okay, and that comes right from our definition. Since all these points on the circle are equidistant from the center, if I connect them with segments, all these segments will be congruent. Okay, the same length. So we can mark all these as congruent. So that's something that's useful about circles, is you can always draw on a radius and know that it's the same as any other radius. So congruent means that they're the same shape and the same size. Well, since all circles are the same shape, the only thing that we need to know is, are they the same size? And the thing that determines how big they are is the size of the radius. So if you have two circles that have the same radius, that means that they are congruent. Now I'll start talking about how segments and lines interact with circles. Segments, you can have a segment that is inside, that touches 2 points on the circle. Okay, so a segment whose endpoints are on the circle is called a chord. A specific chord that you've probably dealt with before is a diameter. It's a diameter when it goes to the center. So if this is the center of our circle, then this would be a diameter. If we have lines, okay, so if we were to extend any of these chords and make them lines, they then become secants. Okay, so a line that intersects a circle in 2 points is called a secant. So we can have lines that go through. We can have lines that don't touch the circle at all, you know, lines sitting out here. Or the last thing we could have is a line that intersects a circle in exactly 1 point. This is called a tangent line. And the place where it meets the circle, so the 1 point that it shares with the circle, is the point of tangency. Okay, so if I kind of blow up my picture, and we imagine these are points on my circle. Okay, so it's kind of rounded out like this. If this is my point of tangency, there's a line that comes and just touches that 1 point. Okay, even though there's an infinite number of points, so even if we blew up the circle, it'd still look, you know, like this. But all these points lined up, there's only one that is shared between the line and the circle. And that's what makes a tangent line tangent. Okay. There's common tangents. These are lines that are tangent to 2 or more circles. There's 2 types. There's internal. Internal means in between the circles. And then there's external, which is just the opposite. So not in between the circles. So let's see if I can draw a good one here. Okay, this would be a common internal tangent. It's tangent to this circle, and it's also tangent to this one, and it's in between the 2 circles. And there's going to be 2 of those. There's going to be this one. There's also going to be, you know, the one that does this, which isn't as good as my first one. But okay, those would be internal tangents. The external, let's get these out of the way. The external don't go in between, so they would just kind of sit either on the top or bottom of both circles. So there's an external tangent, and there'd be two of these. Okay, those would be your two common external tangents. Circles can be tangent to each other also. Okay, so if these two circles just share one point in common, okay, it'd be like having two hula hoops pushed up against each other. They're only going to touch in one spot. The other way that circles can interact is they can be concentric. So they can be tangent, they share one point. They can be intersecting, which would just be, if they touch in 2 points, that'd be intersecting circles. I'll put another tangent one up here. Okay, or you can have concentric, which means that they have the same center. So if this is my center point, there's a circle with that center. There's another circle with that center. There's another one. Okay, you get this bullseye looking thing. Okay, they don't necessarily have to be evenly spaced. I could have one that's way out here. But these are all concentric circles because they all share the same center. All right, another thing about tangents is if a line is tangent to a circle, then it makes a right angle with the radius that connects to the point of tangency. Okay, so all these points that all these radii going from the center to their tangent line are perpendicular. Okay, so it's important to know that if we connect the radii here, okay, they're not going to make right angles with each other, but if there's a line that went right through here, right through that point of tangency, then these would both make right angles with that. Okay? All right. So some relations and formulas you need to know. So if you take 2 times the radius, that equals the diameter. The area formula is pi times the radius squared. Circumference is 2 pi times the radius. Since 2r is a diameter, you could also say this is just pi times the diameter. Okay, the last thing you should know about tangents, which you could kind of figure out, let's say I've got 2 tangents coming from the same point here. Okay, well that means that I'd have these radii going out to both points of tangency, and I could connect the point to the center, and I get 2 right triangles here. Since these are congruent because they're both the same radius, and this is congruent by the reflexive property, and we have right angles, the hypotenuse leg theorem says that these triangles are congruent, which allows us to say that these segments are congruent. So if you have 2 tangents coming from the same point, then they're congruent, okay, at least from the point to the point of tangency.